NVIDIA CEO Jensen Huang just took the stage at GTC 25 and he delivered big. Here's a rundown of what he shared about Omniverse, digital twins, physical AI, and robotics. Insights you will not want to miss. Digital twins stole the show at NVIDIA's GTC 25. Unlike past years where Jensen gave them a quick nod, this time they were everywhere, front and center. The biggest statement from Jensen in regards to digital twins was, in every industry, every company that has factories will have two factories in the future. The factory for what they build and the factory for the mathematics and the AI. Think of our car factory. It will have a factory for making cars and a factory for the AI that builds the cars. Jensen kicked things off at GTC with a digital twin of NVIDIA's headquarters built using Gaussian splatting, which is a leap beyond old-school 3D laser scanning. As he dug into NVIDIA's business, we saw more. Digital twins of the NVIDIA campus, data centers, and even vehicles in San Jose tied to autonomous driving. Jensen paid tribute to CUDA's creators' roots with an inspiring video.
To the creators, the pioneers, the builders of the future, CUDA was made for you.
And then dropped a mind-blowing stat. Blackwell, which is NVIDIA's latest GPU architecture, is 50,000 times faster than the first CUDA chip. That jump shrinks the gap between simulation and real-time digital twins, fusing manufacturing, robotics, and AI. As a quick note here, Jensen highlighted NVIDIA's work with several CUDA libraries across different industries. For the computer-aided engineering industry, he emphasized partnerships with companies like Cadence, Synopsys, Dassault Systems, and Ansys to accelerate key EDA, which is electronic design automation, and CAE programs and libraries. Take Ansys for example, a top simulation software leader. They just announced that they are integrating with NVIDIA Omniverse starting Q3 of 2025. This acceleration of key programs and libraries means that 3D scenes will be more realistic, adhering closely to the laws of physics. That's a big win for creating precise digital twins across industries. Omniverse took center stage at GTC 25, with Jensen calling it the operating system for physical AI. Jensen leveraged Omniverse to unveil the concept of AI factories, which are advanced data centers that generate tokens, which are units of intelligent output using AI, rather than just storing or retrieving data. He announced that NVIDIA is starting to build a digital twin of every data center. He made a bold claim here.
Before you build a data center, you have to build a digital twin.
With data centers driving $47.5 billion in 2024 revenue for NVIDIA, that's a massive play for the digital twins industry. Building an AI factory is a huge complex project with tens of thousands of workers and parts. NVIDIA is using an Omniverse blueprint for AI factory digital twins that enables NVIDIA to design and optimize AI factories long before physical construction starts. The blueprint shifts teams from silos to parallel collaboration, optimizing power usage for AI factories. Real-time simulations run massive what-if scenarios in seconds, not hours. Digital twins streamline instructions for teams and suppliers, testing cost and downtime for a future-proof AI factory. And I gotta say, this was one of the best digital twin demos I have ever seen, so huge props to the NVIDIA team behind it. On the platform side, Jensen announced that NVIDIA has added two technologies to Omniverse. First, Cosmos, which is a generative model that grasps the physical world, conditioned by Omniverse to create grounded, systematic, synthetic data, perfect for scaling AI with realistic outputs. And second, Newton, a physics engine for reinforcement learning, where verifiable rewards take center stage. In language models, rewards are often subjective, think word accuracy or coherence. For robotics, it's concrete. It's the laws of physics. This GPU-accelerated engine handles fine-grained, rigid, and soft bodies, training tactile feedback, precise motor skills, and actuator controls in real time. Newton is designed to be compatible with MuJoCo, which is an open-source physics framework acquired by Google DeepMind in 2021 and widely used by roboticists. NVIDIA is now collaborating with DeepMind and Disney Research to advance this next-gen Newton engine. To wrap things up at GTC 25, Jensen wove physical AI and robotics into a unified story. He revisited a graph from CES 2025, tracing NVIDIA's journey from 2012's AlexNet and Perception AI to today's generative AI and now toward agentic and physical AI. Physical AI, as he explained, is AI that gets the real world. Things like friction, inertia, cause and effect, object permanence, unlocking the brains for tomorrow's robots, especially humanoids. Jensen framed robotics as the next multi-trillion-dollar frontier driven by physical AI. He highlighted a global labor crisis. By the end of the decade, a 15 million worker shortage worldwide, including 2.3 million in US manufacturing alone. Humanoid robots powered by physical AI could bridge that gap, transforming industries at warp speed. And NVIDIA is betting big. Jensen sees robots potentially outscaling every other sector at NVIDIA's business. How? Well, NVIDIA's ecosystem ties it all together. Jensen mentioned that there are 3 computers built by NVIDIA that enable a continuous loop of robot AI simulation, training, testing, and real-world experience. While internet-scale data gives robots reasoning, action data, which is hard and expensive to capture, is the bottleneck. With blueprints built on NVIDIA Omniverse and Cosmos, developers can generate massive amounts of diverse synthetic data for training robot policies. Developers start with real sensor or demo data in Omniverse, then use Cosmos, which, as previously mentioned, is a generative model conditioned on physics, to multiply it into massive photoreal synthetic datasets. Isaac Lab refines these post-training robot policies via imitation learning, say cloning scales from a Vision Pro demo, or reinforcement feedback. Testing is next. Omniverse's digital twins simulate these policies in real-world dynamics, for example, domain randomization, physics, high-fidelity sensors, for software and hardware-in-the-loop validation. When multiple robots are required to work together, NVIDIA provides Mega, which is a digital twin blueprint built in Omniverse that lets developers test fleets of post-trained policies at scale, such as orchestrating multiple robots in a virtual factory. It's a pipeline from code to reality. As a final announcement, NVIDIA rolled out GROOT N1, which is an open-source, slick, generalist foundation model for humanoid robots. It's powered by synthetic data and simulation, rocking a dual system setup mimicking fast and slow thinking, which is similar to human cognitive processing. And that wraps up NVIDIA GTC 2025. I'm Kevin, co-founder of Twintivo. Thanks for watching and see you in the next video.